Right, hi Year 11. Just going to finish off going through some of these questions. I'd like you to have a go at the questions yourself first and then watch the video and go through them. This is the question that we were doing in the last lesson where we didn't quite finish it. So I'm going to do it from the beginning. Okay, so what I need to first do is sort of put in some information. I'm going to go from A to B. We're told that that is the vector x. So let's put that there. And I'm told the vector A to C is y. And the m is the middle of that. So I'm just going to label that. That's a half y. And that's a half y. So A to m is a half y. And m to c is a half y. And what I'm asked to do is find A to n. A to n. So that is, I suppose, this vector here. And what we did in class, we discussed that what we wanted to do was go from A to C and then C to N. The problem being we've got no information about what C to N is. And it's difficult to know really. But what we can do is we can find out what C to B is. So let's find C to B. Well, C to B, again, I'm just going to change colour here. C to B is I'm going to go this way down from C to A, and then I'm going to go from A to B. So what I'm doing is I'm going the wrong way down AC. So I'm going negative Y, and I'm going the right way down AB, so that's a positive X. So C to B is minus y plus x. So therefore C to n, because it's halfway, C to n is halfway between C and B, then it's a half minus a half y plus a half x. So that's C to n. So now I can find A to n, because A to n is the same as A to C plus C to n. Okay, A to n is equal to, AC is y, plus C to n, which is minus a half y plus a half x. So the answer appears to be a half y plus a half x. So let's just put that in there. Half y plus a half x is A to n. So hang on, so I put that in the wrong place. Let's just make sure that's right. It's a half y plus a half x. That's A to n, the blue vector. Okay, right, let's keep that in mind. And let's also write down what C to B was, which was minus y plus x, just in case we need that. And we know that n is in the middle. Okay, so let's just delete that. So now I've got all of that information sort of stored. What I need to do now is find out, because I'm asked to show that MN is parallel to AB. Okay, well, let's find MN. Okay, which would be this one here. How can I get there? Well, I think the best way to get from M to N is I'm going to go down this red path. I'm going to go from M to C and then C to N. Okay? So what we're going to do is we're going to go from M to C. We'll already know that. So M to N is equal to MC plus CN. Okay, and what I know is that that's a half y plus a half of minus y plus x, which is, well, a half y minus a half x plus is a half x. So what can we conclude? MN is equal to a half x and AB is equal to x. Therefore, MN is parallel to AB. And we also know that vector MN is equal to a half the magnitude of AB. MN is half the magnitude of AB. Okay, I hope that makes sense. You can always message me on Teams if you need any help. Okay. Right, let's just flick over to the next question. Okay, so you stop your video and have a go at it first, and then I'll go through it in the video. Okay. Right, so hopefully you've done that. So let's just label everything. A to B is 2x, and let's put arrows in. Didn't do that last time. B to C is 2y, and is n in the middle. N is the midpoint, so that must mean that's a y. That's a y with these directions. AD is 6y, and M is the midpoint, so that's 3y with these directions here and 3y here. What we want to do is find the vector n to m. That's this vector here. Okay, so how am I going to do that? Well, I've got options, but the easiest option I think is go down the path where I've got vectors already. So I'm going to go from n to b, b to a to m. So I can say that the vector n to m is equal to n to b plus b to a plus a to m. Right, n to b is negative y, b to a is negative 2x, and a to m is positive 3y. So it becomes 2y minus 2x, which I can write, if I want to, as 2 lots of y minus x. Okay? Right, what we've got to do now is prove P is the midpoint of M, N, M, and Q is the midpoint of CD. Sorry, let's not say that. It says P is the midpoint of NM. Okay, so let's just mark that in. So here's P. Okay, and Q is the midpoint of CD. Okay, so what we want to do is prove that PQ, which is this, is parallel to AD. Okay, so what we know, it's easy. It's an easy start. We know that AD is equal to 6y. Okay, we want to prove that PQ is parallel to AD. So what I've got to do is I'm going to have to find out some information about PQ. So how am I going to get from P to Q? What I'm going to do is I'm going to go from P to M, M to D, D to Q. Right, what I know is that P to M is a half my answer for the first question. Let me just write this down properly. PQ is equal to PM plus MD plus DQ. Now P to M is a half the first question, so that's y minus x. MD is given already, that's plus 3y. D to Q is what I don't know, okay? What I do know is that D to Q is half of D to C. So what I'm going to have to do first of all is find out what D to C is. Well, D to C is I'm going to go all the way round here. Okay, so I will be going minus 3y, which is D to M. And then I'm going in the wrong direction around N to M. So that's going to be plus 2x minus 2y. Okay, so that's negative of NM. And then I'm going to be adding a y, which is N to C. Let's collect the terms. I'm getting minus 5, I'm getting 2x minus 4y, which means that D to Q is a half of that, so that's x minus 2y. So D to Q is x minus 2y, and now we're going to simplify all of that. So what do I end up with? Notice how x's cancel away, that's promising. I'm going to get y plus 3y is 4y, minus 2 is 2y. Okay, P to Q is 2y. Therefore, PQ is parallel to AD, okay, because the direction element of the vector is, for both of them, is y. And what we could say is the magnitude of AD is 3 times PQ. Okay, that is to say that AD is 3 times as long as PQ. Okay, that's what we can imply from that because those values tell us so. Okay, right, one more question. Okay, let's have a look at this one. Okay, ABCD is a parallelogram, that's important. E is a point on AC such that AE is 2/3 AC. DA is 6A, it's all marked on here. DC is 6E. What we've got to do is find the vector DE. Okay, vector DE. So we're going from D to E, that's the green line, which I can't do, so I need another direction. What I'm going to do is I'm going to go, let's go this way. I'm going to go from D to C and then C to E. So D to E is the same as DC top to tail with CE, so I add them together. Okay, DC is easy, that is 6C, that's the vector 6C. C to E is not so easy because we don't know anything about C to A. So what I need to do now is, as a side note, I need to find C to A. Well, C to A is minus 6C plus 6A, okay? And what we know about C to E is it is got to be 1/3 of C to A. So it's going to be minus 2C plus 2A. I hope that makes sense. Okay, so we're minusing 2C and we're adding 2A, and so we're getting 4C plus 2A. Vector DE is 4C plus 2A. Okay, the midpoint of CB is M. So let's say that's somewhere like here. There's M. Okay, prove that DEM is a straight line. Now, what we're going to do here, we've already shown what the vector is for, pick a different colour, for D to E. We just showed that, we already answered it. So what I'm going to do now is I'm also going to find out the vector for E to M. Okay? Right, now, to go from E to M, I'm going to go like this. I'm going to go from E to C, and then I'm going to add C to M. So what I'm effectively doing is this. I'm going E to C and then C to M. So I need some information here. Well, I already worked out what C to E was. C to E was this. Okay, that was C to E. I already worked it out. Okay, but it's in the wrong direction. I need to go to EC, so I'm going to reverse it. So what I know is that E to C is 2C minus 2A. It's the negative of CE. I also know that C to M is halfway between C to B, and I know what C to B is because it's a parallelogram. So if it's a parallelogram, CB must be the same vector and same magnitude, so the same magnitude and same direction as D to A. So I know that C to M must be 3A. And so what do we end up with? We're going to end up with 2C plus A. Okay? 2C plus A. That is what E to M is. So D to E is equal to 4C plus 2A. And E to M is equal to 2C plus A. It can therefore be shown, well, let's just mess around with DE. DE is equal to 2 lots of 2C plus A. Notice that the direction components, okay, this and this are exactly the same. The only difference between DE and EM is that DE is longer, okay? So it's got a larger magnitude. So those two vectors are parallel, but they also share a point. They share this point E. They're parallel and they share a point. So we can say EM is parallel to DE and share point E. Therefore, DEM are collinear. They are in a straight line, okay? And that's how you do it. That's how you proved it, okay? So let me know if you've got any questions. If you need help on Teams, even though I'm not there, I'll get back to you as soon as I can. All right, apart from that, you've got some My iMaths to do and a Microsoft form to do. If you finish all of that, then I'd expect you to start working through some past papers, please. Okay.